Welcome to Study Life. In our previous videos in current electricity, we've learned how to solve complex networks using series connections, parallel connections and the delta to star method. In this video, we're going to learn the star to delta conversion. What does the star network look like? So this is what a star network looks like. Let me just take it behind. Yes, this is what a star network looks like. Let me just draw, imagine a triangle around it. Name this point over here as vertex A. Therefore, this resistance in here is basically RA. Okay, let me just call this point as B, and therefore this resistance becomes RB. Similarly, this connection here, let's say it is C, and the resistance in here is RC. I need to work on this. I basically need to work on this. Remember the last video how we calculated R across AB, resistance across BC, resistance across AC. Very similarly, we are going to work on it even now. If I decide on to calculate the resistance across AB, what should be my approach? My approach is very simple. I'll have to add RA and RB in series, in neglecting RC, because the very moment I see RC, it is nothing but into an open connection. Since it is into an open connection, we could easily neglect RC. So what remains with us is simple RA plus RB. What if I decide on to calculate the resistance across BC? Resistance across the point B and the point C. How will I write it? I'll just add a series value of RB and RC. I will neglect this RA. Why will I neglect this RA? Because it is into an open connection. So let me just write it down. It's RB plus RC. Similar terms, if I decide on to write resistance across RAC, resistance across point A and point C, it is equal to RA plus RC. Simple and easy, right? But this is not always possible. We might have to do something, and let me just try and convert this into the delta network. What does the delta network look like? This is again got three vertices. Let me just name this as A, this point here as B, and this point here as C. Okay? I'll call this resistance as R1, this resistance here as R2, this resistance here as R3. Let me just write it nicely. Yes. So if I wanted to calculate the resistance across point A and B, so what is RAB in this scenario? How will I write RAB in this scenario? In this scenario, RAB is nothing but a series connection of R3 and R2 in parallel to R1. That means it can be written as R3 plus R2, that is in parallel to R1. Not difficult at all. If I decide on to calculate the resistance across B and C, resistance across B and C is nothing but a series connection of R1, R3, which is in turn parallel to R2. So let me just write it down. It's nothing but R1 plus R3 parallel to R2. Similar terms, R of AC, resistance across AC. So this is my A, this is my C. I want to calculate the resistance across this connection. So it's like connecting R1 and R2 in series and making this parallel to R3. So what does this look like? This looks like R1 plus R2 in parallel to R3. Simple, easy, very nice. But they might ask you again to calculate my value of R1, R2 and R3. We've got resistance across terminals, right? We don't have individual values of R1, R2, R3. What if they decide on to ask? See, R1 will have a value. Achha, how will I find out? I'll have to equate them. I will have to do nothing but simply equate them and work on it. What will be the value of R1? Where is R1 located? Here. Okay? This R1 is located around A and B. So the value of R1 will be written as RA into RB divided by RA into RB plus RB into RC plus RA into RC. Simple. It's very much like the previous one, but this time we have certain differences here. Let's work on with our next connection. What is our next connection? R2. What is our next resistor beta? It is R2. And how will you compute the value of R2? Let's work on it. R2 should be equal to, where is R2 located? R2 is located here, that is somewhere here, and that is between RB and RC. Can you see this thing? Can you simply direct imagine? You don't have to imagine, you can see on the screen. It's RB and RC. Let me just write it down. It's RB RC divided by RA-RB plus RB-RC plus RA-RC. What if I decide to calculate the value of R3? R3 is here, right? Can you see this R3? This R3 is somehow manipulated between resistance A and resistance B. So if I want to calculate R3, R3 is nothing but RA-RB divided by RA-RB plus RB-RC plus RC-RA. Simple and easy. But these sort of connections are not easy if you do not know it. Complex connections can actually make you lose marks. So it's always a very good suggestion for you people to solve all these problems theory, make them very nice, and then start solving questions from the entrances. So as of now, I'll take a leave, and I wish to see you people in our next video. Until then, keep learning and stay tuned with Study Live.